I'm Maria Prignolato and I'm a lecturer in civil engineering at the University of Bristol. A digital twin is a realistic digital representation of an asset, process or system with a peculiar characteristic of connection, called twinning, between the real world and its digital representation. By improving design, maintenance and management, they are considered a key step in the digital transformation of the infrastructure and construction sectors. The UK already has a promising background of developing digital twins, such as the dedicated program of the Centre for Digital Built Britain. Our research looks at how digital twins can be made deliverable in the civil engineering sector. It focuses on the need to provide a real tangible case from its development to the delivery, proposing a method that can work across civil infrastructure. At the University of Bristol, within UCRIC and the Urban Observatory, we are building a digital twin of the Clifton Suspension Bridge as a proof of concept of such an idea. Digital twins have been proven successful in manufacturing, where they allowed faster production time, cost reduction, and prediction of system malfunctions. However, in civil engineering, their actual application is still largely at the prototype stage. Digital twins are a new trend, and industry and research are currently overwhelmed by competing definitions and unclear processes for developing them. Practical case studies are rare, and this is delaying the sector from establishing digital twins in practice. Three main barriers can be identified. First, cost and value proposition. The return on the investment into digital twins have not been demonstrated, as well as benefits to developers and society. Second, regulation and legislative issues. Standards are developing for data management, such as privacy, security, and storage. Third, cultural change. Digital twins imply a transition to new procedures and routines proper of a digital environment. This transition implies major change in the mindset, skills, and procedures of companies and operators. A national digital twin cannot happen without support from smaller-scale digital twins. More case studies are needed to demonstrate usefulness and economic return. In theory, digital twins for the built environment can be a reality in a few years, but we still need a pathway to overcome barriers to make this happen in practice. Our study was functional for identifying the challenges to implementation. For example, the need to overcome competing definitions and unclear processes, the need of standard protocols for data management, the need to support engineering companies in the transition from manual to digital practice, the need to clarify the value of digital twins for future users as well as the overall benefits. Although the government strongly supports for digital twins, a big gap is still present between roadmaps and actions. There has been some pioneering work in respect of this transition, such as some agreed protocols for governance and management, but there is still a need for change in practice. We are missing real case studies, demonstrators in the built environment, needed as components of the national digital twin. Securing the value of effective use of digital twins requires support from government and other public bodies, through setting standard protocols for data management, metrics to demonstrate the value and benefits of digital twins, as well as reporting criteria. Research and developing funding mechanisms, such as the Innovate UK, could be directed to specifically support digital twin case studies. In parallel, existing investment should be maintained, particularly in the development of skills and digital work, as well as supporting digital technologies such as the 5G. Therefore, MPs should continue to champion calls for increased funding for digital twins. I make myself available to share my expertise about how to facilitate digital twin case studies and how to champion research and change to allow growth in this area.